Okay, so we left off last week talking about derivatives as rates, and we were doing kinematics, right? And we had, this is the problem we were looking at. This is the one where standing right above the valley floor on Yosemite, you put the rifle out just right over the edge, you shoot a bullet up in the air, and it's coated with sliprium, so there's no air resistance. It leaves with a muzzle velocity of 1,000 meters per second, which is fast. I mean, that's like, 3,300 feet per second. That's fast, but that's like what a, like what a high velocity rifle bullet would be. That's pretty reasonable. And we used this equation to do some stuff, right? They gave us the vertical position, because it's just vertical motion, y, which is height as a function of time. You guys told me correctly to differentiate that to find the velocity function. And then what did we do here? You answered the question, how long does the bullet take to reach its highest point, by asking when is the velocity equal to 0, which is exactly right. You have to just identify which frame in that video are you interested in. Well, you're interested in the frame where the velocity is 0 because that's going to correspond to the highest point, right? Everybody knows that. Where the velocity changes from being positive to negative is when it's at its apex. Okay, good. And so we got an answer of about 102.04 seconds. And we plugged that in and we got an answer of 52,020 meters, so over 52 kilometers. And I think the last thing I asked you before we were done was, is that realistic? And the answer was, I mean, would it really do that? No, not even close. How come? Because sliprium doesn't, I haven't quite as soon as I trademark it and get it on the market, it'll exist, but it's not there yet. And so for now, bullets are affected by air resistance. In fact, they're affected massively by air resistance. And so it turns out it's going to go, I mean, it's just a small fraction of that amount is how high it actually goes. Okay. All right, so again, assuming this is, we'll look into the future a few weeks when this is on the market and there is no air resistance. The next question is, how long does the bullet take to reach the floor of Yosemite Valley? Okay, and let's assume here that, well, here are the derivatives that we've taken, or the next one, I don't know if we actually took this derivative, but the derivative of velocity would give us acceleration, and it tells us the acceleration is a constant negative 9.8. What are the units for all these, by the way, remember? What are we measuring in? Distance we're measuring in meters, right? All our units were involved meters, and what was our time? Seconds, yeah. So what would the units of acceleration be, which are the rate of change of velocity? Meters per second, good. Which is, we would abbreviate as meters per second squared. Who's in physics? That's an important number, isn't it? What is that negative 9.8? That's the acceleration of gravity where? Yeah, near the surface of the Earth, right? Okay. Good. Okay, so how are we going to answer this? How long does it take the bullet to reach the floor of Yosemite Valley? So we're solving for what variable here? Time, right. Okay, good. So we're solving for t. So again, we're really just looking for a frame number, aren't we? Right? Or for a specific frame. We don't know the time of that frame yet. That's what we're trying to find. Well, I don't know. How could you identify, what's another way of, we don't know the time yet, but what's another way of identifying the frame that we're interested in here? Oh, the position. Okay, so what would the position be when it's on the floor of Yosemite? Well, okay, if we go back here, remember we said that, well, yeah, okay, so I don't know if I ever said this explicitly. I think I did on the previous page before this one. But we're measuring from 0 is at the valley floor. And the way we can kind of show that is, what is y of 0? Meaning our initial position. If I plug in t equals 0, which is the moment we shoot the gun, It's 1,000. Okay, so it's starting from 1,000 meters above the valley floor, right? So then we want to know when it's at the valley floor, which would be y equals 0. Okay, give me thumbs on that. Everybody all good with that logic? Okay. All right, so then what question do I ask the physics gods here? Well, yeah, we want to know for what values of t, what value or values is y equal to 0. That's what identifies the frame we're interested in, is this, right? Y equals 0. So as you said, we're just going to set the position function equal to 0 and solve. Okay, now we could do that, right? That's just a quadratic equation. So we could use the quadratic formula, or we could complete the square, or whatever. I mean, we could certainly solve that. But that's just a bunch of numerical stuff. We don't want to waste our time with that. We'll use technology to do that, right? So let's use Desmos. If we graph that function, y equals 1,000t minus 4.9t squared plus 1,000. Well, it's not surprising it's a parabola, is it? Right, because y is that's a quadratic function in the variable t, right? Say quadratic function in t, so we should expect it to be a parabola. Okay, let's clarify something here. Is this showing us the trajectory of the bullet as it moves out it moves down range and lands somewhere? No, it's not, right? This is not x as a function, or y as a function of x. It's y as a function of t, right? So this is telling us height as a function of time, because the bullet is actually not moving horizontally at all, right? It's just going straight up and straight down. So it's always really important when you look at graphs to put yourself in the right plane. You got to think about this. Think in terms of a graph. And in our graph, we would have the t-axis down here, horizontally, time. And vertically, we've got the y-axis. And we want to find the places where y is equal to 0. And so if I look at this parabola, I get two solutions, actually. I get one that's negative 0.995 seconds and one that's 205.077 seconds. We'll just round to 3 places. So which one are we interested in, probably? This one right here. Okay, good. So this is the answer we're going to plug in. And we get, let's go back here a second. So we're going to get what for an answer then? We wanted we wanted the time. Oh, we found it, right? There it is, 205.077 seconds. Okay. Next question is, how fast is it going when it hits the valley floor? Yeah, right. Now we know the frame. We know the specific frame, the time index of that frame. Now we're just going to go to that frame, and instead of looking at position, we're going to look at the velocity sensor, right? Whatever the velocity of the bullet is, by plugging in that value of t. And we get v of 205.077, and we'll just, we can just evaluate that directly, and we get an answer of that, okay? Negative 1,009.7546. Okay, does that pass the smell test? Does that seem right? Okay, how come? Going down. How about the magnitude? Does that seem about right? What would it... Well, no, with my, I'm with my slip rim, yeah. So, what would you expect as the bullet came whizzing back down by the rifle? And by the way, you have a real steady hand, and you're just holding the rifle out there, and in the process of, while the bullet's going up and down, you've taken everything off except the barrel, and so the bullet is passing right through the barrel on its way down. Okay. What would you expect its velocity to be right as it gets to the barrel? Okay, so it had a velocity of positive 1,000 meters per second. So it'd be negative, wouldn't it, right? And that's taking advantage of really an important symmetry here, the time symmetry of the situation. This is pretty cool to think about, right? If we look at this graph, this parabola is symmetrical about its axis of symmetry. And what is the axis of symmetry? Well, it's just going to be a vertical line through the t-axis at a time that we remember from a previous page, right? We know what it is. It's 102.04, roughly, right? That's going to be the time when it hits the apex, which is the vertex of that parabola, right? And so the vertical equation of this line, let me just make this a little smaller for just a second here, if I do that. Okay, the equation of that line, we know. The equation of that line is just t equals 102.04, right? Well, this parabola is symmetrical about that line, parabolas are, and so that tells us that this thing has time symmetry about that axis. The path up is symmetrical to the path down, right? The velocities are just opposites is all, right? Their slopes are just opposites on opposite sides of that curve. Make sense? But the heights are the same. Okay? So yeah, we would expect the velocity here to be the exact opposite of there, right? At either end. The slopes or the lines are just going to be, they're going to have the same magnitude of slope but opposite directions. Okay? So, why am I quizzing you on this stuff? Because I wanted you to defend why you think this is a reasonable answer. Okay, so then if it passes by the barrel at negative 1,000 meters per second, why is it hitting the valley floor at a slightly higher negative velocity? Okay, because it can continue to accelerate on the way down, but it's going pretty fast, and so it doesn't have very much time to accelerate, does it? Right, so it's not picking up that much additional speed because it's going so darn fast already, right? Okay, good. Good. All right, so I think we got this thing figured out. One thing, though, I'm just a little bothered by here, and you should be too. You know, the physics gods, nothing is ever superfluous with the physics gods. Everything has some meaning. What about this other zero? What's going on there? We wanted to know where this thing where y equals 0, and one answer was negative 0.995 seconds. What in the world is that all about? Ah, okay. Now the physics guys don't really understand. They're above just common everyday items. They don't really understand rifles. All they understand is kinematics and some math, right? So they know that they see that there's this tube that the bullet is emerging from at t equals 0 when we start our stopwatch with a velocity of positive 1,000, and they don't really understand rifles. They just know that those are the initial conditions, right, at t equals 0. As far as they're concerned, that bullet probably started on the valley floor and went whizzing up through this tube and exited the tube with a velocity of 1,000. They don't really know that they don't know about gunpowder and stuff. I mean, they just think it started down there and came whizzing up. So for that to have happened, what would those conditions have to have been? How much time would have elapsed prior to the bullet exiting this tube that they see? Yeah, 0.995 seconds. That many seconds earlier. So what's a negative time? I mean, negative time just means 0.995 seconds before the arbitrary time that we called 0, right? Negative time exists. I'll prove it to you. Okay, ready? I'm going to snap my fingers once. I'm going to snap them again, and all of a sudden that first snap is at a negative time. If the second snap is when I decide to call the time 0, then the first one would have been previous to that, prior to that, so it would have been a negative time. Okay, no big deal. So that's how they interpret this, right? They interpret this as the bullet passing by ground level slightly less than a second earlier with a pretty high velocity. In fact, what velocity do you think that would have been, I wonder? Opposite of that one, right? Because that's how fast it was going when it hit the ground on the downward journey. Therefore, that's exactly how fast it would have been, but in the positive direction, on the upward journey at ground level, okay? So even though we don't necessarily need this point, that's not the one we're interested in the context of our problem. It does have some meaning in a different universe where it started on the valley floor instead of being shot out of the rifle, okay? Make sense? All right. Okay, I'm gonna give you a choice here.